So today you're going to start by looking at the notes I posted, not these, the other ones about the principles and everything, and you're going to read those, okay? So make sure you read those before you start looking at this. Then we're going to look at this, and this talks about what was in those notes. The fundamental counting principle, permutations, combinations are all ways we use to figure out how many different ways we can arrange an object. So we're just going to look at some examples. The first one says, suppose that 7 people enter a swim meet. Assuming there are no ties, and how many ways could the gold, silver, and bronze medals be awarded? Now, in this situation, the order those people win is important. Order matters, because me getting a bronze is not the same as me getting a gold medal. So because order matters, we use permutations. Now, for permutations, we put the total number of people first, so it's going to be written like this, and then we put a big P saying this is permutation, and then how many different spots we have, okay? On that other note sheet I gave you, it showed you how to do this by hand. You don't have to do it by hand. It's in graphing calculators, but even without a graphing calculator, if you just Google permutation calculator, you'll be able to type this in, okay? And it's in a permutation calculator. It's going to be written as NPR, actually, like this. So NPR, and you're just going to put the 7 in for the N and the 3 in for the R. Okay, and then hit enter and it'll tell you that 210. Okay, now, next example. How many different ways can you elect a chairman and a co-chairman of a committee if you have 10 people to choose from? Again, the order matters, because whether I'm chairman or whether I'm vice chairman makes a huge difference. So because the order matters, this is what we call a permutation. Okay, so we're going to do 10. That's how many people we have to choose from. P2, because there's 2 spots. Type it in that permutation calculator. You don't need to do this by hand. And we get 90 different ways. That's how many ways we could choose. Okay, next one says, how many different 4-digit PIN numbers are possible? Now, this is different than the last 2 examples. In the last 2 examples, okay, if that 7th place person took 3rd, they can't take 1st, 2nd, 5th, 6th. So that's why we use a permutation. In this situation, it's different because my 4 digits can be used again. It could be 99999. So this is no longer a permutation or a combination. This is just that fundamental counting principle where we're going to multiply the number of possibilities for each spot times each other. Okay, so this is just counting principle because the same digits can be used again and again. So 4-digit, we're talking about numbers. The numbers are 0 to 9. That's actually 10 numbers if you count 0. So I have 10 possible numbers for the first spot, the same 10 possible numbers for the second spot, 10 for the third spot, 10 for the fourth spot. We multiply. That's our fundamental counting principle. We get 10,000. 10,000 different PIN numbers out there. Okay, next example. John bought a machine to make fresh juice. He has 5 different fruits: strawberries, oranges, apples, pineapple, and lemons. If he uses only 2 fruits, how many different juice drinks can John make? Okay, in this situation, order does not matter. I'm going to put them all in my blender. I'm going to blend them up, whatever, squeeze them, make juice together. So because the order does not matter, this is going to be a combination. This is going to give us less choices when order does not matter, okay? So now I had 5 different juices. I'm using 2 of them. I do 5C2. Again, you do not need to do this by hand. You can just type in the computer combination calculator. Okay, make sure you're using combinations and not permutations. Type in 5 and 2 and we get 10. Okay. Next example. How many different 4-letter passwords can be created for a software access if no letter can be used more than once? Okay, now if this said the letters could be reused, that would be our fundamental counting principle. Remember that. Okay, I would just take the possibilities each time. But because I can't use a letter more than once, this is still permutation or combination. In this case, it's permutation because I actually care about the order. Okay, that's the whole anagram thing. Order matters. Now, letter. This time we're talking about letters of the alphabet. There's 26 letters in the alphabet, so I have 26. It's permutation because order matters, and we're choosing 4. That gives us 358,800 different access codes. Okay. All right, last example. A teacher chooses 5 students at random out of a class of 28 to work on a group project together. How many different ways could she choose the students? Okay, I don't care the order. It's going to be the 5 same students, regardless of who I pick first or who I pick last. It's not like the first one I'm picking is the boss. It's just a group. So this, because order does not matter, is going to be a combination, okay? 28 students. We have a combination. We're choosing 5. Again, use the combination calculator on a computer, and you get 98,280. So this is one of the things you're going to be practicing in Delta Math. The other thing you're going to be practicing is review. On the review, I highly recommend like making Venn diagrams and tables and stuff. All right, if you have questions, Zoom me.